organizing this presentation. So, okay, so we know that both temperature and air pollution affect a lot in our daily lives. So we can think of examples of heat waves that lead to increases in deaths, or how air pollution affects increases the number of respiratory diseases. But these effects are also known to be not restricted to health conditions or for long-term exposition. We also know that that their short exposure to both air pollution and temperature may decrease cognitive performance, may decrease productivity, and also may lead to increases in conflict, violence, crime, aggressiveness, which is what this paper is interested in. So to study this relationship, I will use the setting of Rio de Janeiro. And Rio de Janeiro is a nice setting to study this relation because of there are three main factors that are important. Well, Rio is a relatively warm place. Rio is also has non-trivial levels of pollution. And finally, Rio is a really violent city with a high level of gun violence incidents. And just an example here, this table shows what an average month in an average neighborhood looks like in Rio. So as I said, it is relatively warm with an average temperature of 25.8 degrees Celsius. The average concentration of particulate matter PM10 is approximately 35 micrograms per cubic meter, and the average number of days with incidents, with gun-related incidents that this neighborhood experiences is 1.64. As I said, we already know a little bit about this relationship in the literature. We have seen that both heat and air pollution separately may lead to increases in crime, as has been shown in the cities of Los Angeles and Chicago, and also has seen this relationship in many different scenarios. So social media using Twitter data, sports using American football and baseball games, and also domestic violence in Australia. So to study this relationship, I will use two main data sets, one related to the temperature and air pollution information, and the other one related to gun violence. The first one comes from the Monitorar project. This project is part of the air quality agenda developed by the federal government of Brazil. And the goal of this program is to monitor air quality in Brazil. Specifically for Rio, this project has 8 ground stations scattered around the city. And these ground stations provide hourly measurements of particle concentration in the air, pollutants, and also some weather-related information, such as temperature, wind direction, radiation, and so on. Now for the shooting incidents data, I will use data from the Fogo Cruzado project, or Crossfire project. This is a journalistic NGO in Brazil, which has the goal of monitoring crime and violence in Brazil. And what they do is that they capture data from Disque Denúncia, which is a police-related anonymous hotline in which people can call and report crimes, such as reports of gun incidents. And they collect this information and complement it with other sources of information, such as newspapers or social media and in-person investigation. And in the end, they provide a final data set with a precise location of the shooting incidents, the dates, the time, and and also other type of characteristics of the instance. So if there was a police officer involved, the reason of this shooting incident, how many casualties were on this incident, and so on.
A couple of clarification questions on that. So when you say police related, you mean reported to the police, not necessarily involving the police?
No, necessarily involving a police officer. So all of the incidents were reported to the police,
yeah,
but not all of them involve police officers. So if there was a gun shooting between two civilians and it was reported to the police, it is in the data set, but I do not classify as police related.
Okay, so another question that's sort of somewhat related is, will you be able to distinguish, for instance, hotter weather or different particular conditions are more likely to induce rioting, say, and as a result, you'll get a police response to that, versus under the same conditions, the police respond differently, which may be more connected to the sort of channel. Can you separate those two things based on that? So this is always the police doing shooting, and this one can think of two ways in which that's happening. One, the conditions have changed such that law enforcement is more acute under these conditions, and another is under the same conditions, the police behave differently. Can you separate those?
I tried to do this by looking separately at the police-related incidents and the other incidents, but at a finer scale, I cannot separate between the two. So because I'm only looking at incidents that were reported. So if, for example, the temperature and air pollution are affecting the reporting rate, I could not separate it.
That's a further nuance, but it seems you have the data to be able to sort of conditional on the reporting behaviour,
right,
the extent to which this is driven by police, the way in which the police respond versus the conditions to which they are responding would appear to be captured within the fraud. Maybe.
Yeah, I might, yeah. That's...
I guess the question is like, how much of a description of the incident do you have? Do you have like, someone says like, oh, there was this happening and then the police came and then the police shot, or like, but do you have more of a description of what?
I have this the description, the final description, but only for very few observations. Most of the observations, the description is blank, so there would be not a lot of variation in the sense.
Now, in the first class, you have the number of incidents, right? So you check at least whether the number of incidents reported are more or less the same. So it's giving you something.
Right. Yeah. But sorry, between the number of incidents between police-related incidents and the other
days in which the temperature is higher, days in which the temperature.
Oh,
so because if those are more or less constant and the information that you get is more or less the same,
right,
it's more of a case that you're comparing apples.
Yes. I could do that. I don't do the in this here because I will aggregate at a larger level, but I could do this. Yeah. Okay. Okay. So an example of this first example shows some my data, and the black dots are the 8 stations that are placed in Rio, which I'm using to capture the weather information. The colored portions of this map are the neighborhoods in which I'm using, and the darker the shade of the red, the higher the average temperature that this neighborhood experiences. So from this map, we can see that there is variation in temperature across the neighborhoods of Rio. The next map shows the same information, but now I'm focused on the number of incidents experienced by each neighborhood during the entire period. So the darker the red, the higher the amount of gun-related incidents reported from this neighborhood. In this neighborhood.
Have you tried doing the same map with maximum temperature as opposed to mean temperature?
No, but I could use.
Like, is there a reason why you use mean temperature?
I feel like the mean would be a better approximation of than the higher temperature of the day. So because I will also have measurements from the night, and a lot of incidents happen at night. So that using the maximum temperature, which would be approximately at noon, would I don't know if it would be a a good approximation.
Right. So just on that bit, so you expect the response to be very contemporaneous in the sense that this hour, the temperature of this hour affects my activity in this hour, as opposed to temperature of this hour may affect, let's say 10 hours down the line.
Yeah.
Okay, I see.
So to do the estimations, I aggregate the temperature and the incidence information at the neighborhood year month level. So, and as a consequence of this, I have a lot of zeros in my dependent variable of interest. And to deal with this, I use Poisson regression or Poisson generalized linear model, and in which the dependent variable is the number of days in that neighborhood year month in which I observe an incident with a civilian casualty. And the independent variables of interest are the number of hot days and the number of polluted days in that neighborhood year month. So what are hot and polluted days? These are days that are the average temperature and the average pollution concentration are above the 80th percentile of the temperature or pollution distribution. So these are days that are in the 5th quintile bin of my sample. I also add neighborhood level fixed effects, year month fixed effects, and neighborhood season fixed effects. And
I'm not sure when I interpreted right. So this hot and polluted is kind of like extreme hot or extremely polluted.
so you could classify as extreme because, but that would be sort of, I don't know, out of interpretation. But these are the specific definition is days that are above the 80th percentile of my distribution. These are the top 20% days, both in the temperature and the pollution distribution.
Okay, so if you change like for extreme variable here to like mean or mean pollution.
I could try this, but then it would be assuming the mean, because I'm using the number of days that are above in which the mean temperature in this neighborhood year month was above in the top 20% of the distribution. So by mean, the mean number, by using the mean temperature and mean pollution,
Usually when I think of these climate damages papers, like it's bins of temperature, right? Let's have certain bins of temperature, we have some U-shaped relationship or whatever the shape is that ends up being. So it might be worth looking at that as like the sort of canonical functional form for temperature to have a look at. And then maybe you're not as constrained by this 20% or whatever the threshold is that you pick. That's also going to be somewhat place dependent, right? Whereas if you have something that's just bins of temperature, in principle, there's some, I can think about what that means in some other context.
Right.
So it might be worth looking at.
It makes sense. Temperature, but not the pollution. Why would there be?
Yeah, like if there's a non-linear, yes, normally the pollution temperature is just a linear function of pollution.
Otherwise,
Yeah, okay.
But you could have an interaction, because actually it sounds very interesting to see whether on days that are either more familiar or more hot, there's something that's happening.
I also have the interaction.
And then with the bins, even if you're using pollution as a level, you're still getting this different impact at different levels of temperatures.
So in this specification, I have the interaction. So the interaction between the number of days that are hot and the number of days that are classified as polluted. Only using the 5th quintile bin, the distribution. Yeah. So using this estimation, here are my first results. where I separate between police-related incidents and the other type of incidents. And what we can see from this table is that the effects for both temperature and pollution are stronger for police-related incidents, which might suggest that the fact that police officers usually work in the field are affecting them more and making them more prone to the effects of temperature and pollution, and increasing the number of police-related incidents, the number of days in which I observe a police-related incident in which a civilian was injured or died. In the next table, I separate between weekends and weekdays. The idea here being that in this literature, a possible explanation that might drive this the channel between temperature and pollution to crime and violence is that time use differences between hot days and cold days, and that within that being that on hotter days people tend to go out more, and thus increasing the number of interactions and mechanically increasing the number of violent interactions, and also being that on hotter days, people tend to might increase their alcohol consumption, and thus leading to more aggressive behavior and so on. So I separate between weekends and weekdays by looking at with the idea that on weekends, people tend to have more freedom to allocate their time. So if this channel was indeed happening, this would be captured in these regressions, in which I look into the effects of hot and polluted weekends on the number of weekends in which I observe police-related incidents with a civilian casualty, as compared to the number of hot and polluted weekdays with the number of weekdays in which there is a police-related incidents with a civilian casualty, which is what I observe. The effects for days that are hot and polluted seem to be stronger on weekends than on weekdays, suggesting that this channel is indeed playing a part in the observed relationship. In this table, I also separate between police-related incidents and all incidents, and the effects that I found in the previous table remain here, appearing that the incidence of police-related incidents are higher than all the other types of incidents for the effects of temperature and pollution.
Can I ask, do you control for whether it happens at night or during the day?
No.
Because you said earlier, right, that a lot of events happen at night.
Yeah.
And might it be that during the day, if it's really hot, people stay inside and then they go outside at night, and then maybe that increases the risk of propagation?
That might be the case, yes. But usually in this literature, and what the effect that I have in mind is that on hotter days, people tend to go out more. So it would increase the interaction. So you tend to go to, on a hotter day, you tend to go to the beach, or you tend to go to a park and so on. So this is what the effect that I have in mind. But I can control so I have the time of the incident, so I can control for if the incidents happen at night or.
And sorry if you already mentioned this, but to what extent are hot days correlated with pollution itself? I mean, sometimes the air is more stagnant, it's more polluted. Do you see that?
They are correlated. I don't have the exact number in mind, but I can check this.
It would be worth checking because normally there's a really strong correlation between temperature and pollution, right? You have thermal inversion and pollution can get trapped. And if they're very strongly correlated, that can be an issue.
Yeah, I don't have the number in mind, but yeah. So in conclusion, what I show here is that both hot and polluted days affect together the number of incidents observed. although they are not necessarily complements, they do not increase interaction was not a positive coefficient. They both seem to affect the number of days with police-related incidents observed. And some numbers here show that some takeaway numbers that one extra hot day leads to approximately 6.5 more days with police-related incidents in which a civilian casualty. One extra polluted day leads to approximately 5.7 more days with police-related incidents with a civilian casualty. And the effects are stronger for police-related incidents and for on weekends, indicating that both the incidents, the exposition to these factors and the time use channel may play a part in this relationship observed.
No, I had a small concern. So how large are these neighborhoods? What's the size of a neighborhood in terms of number of people or the size in itself?
So the last numbers that I have in mind are for 2010.
Okay.
And they are around 10,000
I see.
inhabitants per neighborhood.
Right. To what extent is the local variables like temperature and pollution independent of what's happening in these neighborhoods, right? To what extent are these exogenous though? Like, is it possible that the causality is is it possible that there's some sort of a correlation which is going the other way, wherein exceptionally local incidents can also affect actually, the levels of pollution. Let's say there's, congestion, there's a shooting, and then that leads to traffic congestion and stuff like that. So do you have, for example, any IV estimates or something of that sort that gives us a sense that, okay, this is actually exogenous?
I don't have an estimate, IV estimator in mind, but I can try to take that account into.
I see.